All right, it's 12:05. We'll go ahead and get started. Thank you to everyone who has registered for this forum today. My name is Cassie, and I am the coordinator for Partners of Scott County Watersheds, who's putting on this forum. Our mission is to improve the stewardship of Scott County watersheds through education, technical guidance, and volunteer opportunities. We do this by providing you with these monthly educational forums. We also do 3 volunteer water quality monitoring events called snapshots every year. We just wrapped one up on last Saturday, the 18th. We train volunteers how to do simple water quality tests, and then we gather that data and put it in one of the longest running databases in the state. So we have about 20 years of data that we can use to identify trends in our water quality in Scott County and identify areas for possible improvement. We also offer membership and funding partner programs in order to keep these forums as well as the snapshots going. We also will take any extra funds to work on water quality improvement projects. So if you're interested in learning more about donating, please visit our website at partnersofscottcountywatersheds.org to learn more about where that money will go. Also, the next forum is scheduled for Tuesday, August 18th. It will most likely be virtually again from noon to 1. Also, our fall snapshot is currently scheduled for Tuesday, October 6th from 8 to noon. We haven't set up the registration yet. We'll most likely do that closer to August or September, but it will be on the Extreme Cleanup website, www.extremecleanup.org. So with that, I will go ahead and let Kate get started on her presentation.
Hey, can everyone see that? Okay, before I begin, if you want to ask a question, you can type your question in the Q&A box, and then Cassie will get to me at the end. So I say thank you, Abby. Thank you for taking time today to learn a little bit about strategy and research center. For my presentation today, I'm going to be giving an overview of what ION reduction strategy is. I'm getting comments. The audio is working.
Hi, Kay, can you hear me? Hello, Kay?
I think she's going to try to log out and log back in.
Okay, sounds good.
Also, everyone, while we're waiting for Kay to log back in, I forgot to mention that if you have any questions for her, please type them either in the chat or in the question and answer block in your screen, and we will get to those at the end of the presentation.
Are you able to hear me now?
Much better.
Okay.
Yes, very clear.
Okay, so sorry about that. Once again, I want to say thank you for taking the time to learn about the Iowa Nutrient Reduction Strategy and the Iowa Nutrient Research Center. So for my talk today, I'm going to be giving an overview of what the nutrient reduction strategy is, specifically why it matters. Why do we care about nutrients? What are the goals of the nutrient reduction strategy, and what are some of the practices that can be used to meet the goals of this strategy? And then also I'm going to give a brief overview of the role of the Iowa Nutrient Research Center, as well as some of the accomplishments and impacts we've had towards reducing nutrients in Iowa, as well as some of the ongoing research needs that could be addressed in the future. So for those of you in Iowa, you're probably aware that over the last century, we've seen a fairly large shift in the types of crops and the amount of each crop being grown throughout the state. So as you can see, as we move closer to 2020, we're predominantly growing corn and soybeans, either as continuous corn or as a corn soybean rotation. And in this map, this is a map of corn harvested for grain in 2012. Each of these blue dots represents about 10,000 acres of corn harvested for grain. So you can see the state of Iowa, Illinois, Indiana, and then some of the surrounding states in the Midwest have a large amount of corn that's being grown. And the same can be said for soybeans in the area. Now, how does this play into nutrient loss? So if you look at the Midwest and kind of the Mississippi River Basin, which is highlighted in kind of this gold color on the map, you can see that this entire area eventually flows to the Mississippi River towards New Orleans and then drains out into the Gulf of Mexico. When we have corn, soybean, any sort of agriculture, there's going to be nutrients, nitrogen and phosphorus associated with that, and typically nitrogen and phosphorus lost to our waterways. The rivers and streams within the Mississippi River Basin act as basically a conduit for both water as well as the nutrients that are either dissolved or suspended in the water column, which ultimately end up in the Gulf of Mexico. These nutrients cause problems with excess algal growth, and you can see in the red kind of blob in the Gulf of Mexico, that is the Gulf hypoxic zone. This is an area where there's a large amount of nutrient input, particularly nitrogen input, that's causing excess growth of algae, which eventually dies, settles to the bottom, and is taken up by microorganisms. As those microorganisms are taking up that dead material, they're pulling oxygen out of the water. By pulling oxygen out, they're creating the hypoxic zone, or the dead zone in the Gulf of Mexico. They're creating conditions where the oxygen level is so low in the area that it either is unable to support aquatic life or it has very low levels of aquatic life. I believe that last year, the size of the hypoxic zone in the Gulf of Mexico was approximately the size of the state of Massachusetts. This is a very large area that cannot adequately support life because of the excess nutrients coming from the Mississippi River Basin. Now, this is a problem. Nutrient loss is a problem, not just because of the Gulf of Mexico hypoxia. Nutrient loss can also cause problems in local waterways. The US EPA has a drinking water standard of 10 parts per million for nitrate. Anything above this can potentially have harmful health effects, especially for infants. So excess nutrients in our waterways can lead to us not meeting our drinking water requirements or having to upgrade our treatment systems so that we can make sure we're not taking in high nitrate level water. Can also have the occurrence of algal blooms like you see in the picture on the right. These algal blooms tend to be unsightly, they might smell bad, they can interfere with recreation. There's also the potential that some of these algal blooms in the state are also harmful algal blooms. Harmful algal blooms differ from just kind of your standard algal bloom in that they release a toxin. The most common toxin is microcystin, and this microcystin has the potential to harm wildlife, to harm pets, as well as to harm humans who either ingest the water or even if you get it on your skin, it can cause some adverse reactions. Now, just like in the Gulf of Mexico, where there's the hypoxic zone, the low oxygen zone, some of the lakes throughout Iowa also may end up with hypoxic conditions because of this excess algal growth, which can impair things like sport fisheries, as well as native fish habitat. And then there's the local water body impairments. So not only do we get algal blooms from excess nutrients in our waterways, we also tend to see an increase in submerged aquatic vegetation, which nothing wrong with submerged aquatic vegetation, but if it's in an area like a marina, if you have a large amount of vegetation under the water, this causes potential boating hazards, where you can get your boat motor kind of wrapped up in the vegetation. It can make it hard for recreational opportunities, and it's usually something that people will go in and actually remove the submerged aquatic vegetation. So it's a nuisance to actually get out to make the water usable for your specific purpose. If you look at nitrogen and phosphorus contributions from the Mississippi River Basin, you can see that a lot of the nitrogen and phosphorus comes from the Midwest, specifically Iowa, Illinois, Indiana, a little bit of Ohio, and then along the Mississippi River itself going south. And it's pretty similar for phosphorus as well. I should mention that the darker the color, the more nitrogen or phosphorus we're seeing coming from that area. So just like with the nitrogen, with phosphorus, a lot of this phosphorus is coming from Iowa, Indiana, Illinois, a little bit more from places like Kentucky and Missouri, and then down south along the Mississippi River. So since this is obviously not just an Iowa problem, but a Midwest problem, the US EPA set up a Mississippi River Gulf of Mexico Watershed Nutrient Task Force. This task force put together the 2008 Gulf Hypoxia Action Plan, and their main focus was trying to come up with a way to reduce the amount of nitrogen and phosphorus making it to the Gulf of Mexico, thereby reducing the overall size of the hypoxic zone in the Gulf. As part of this action plan, 12 states, including Iowa, were asked to develop and implement their own strategies for nutrient reduction within their boundaries. And to create these nutrient reduction strategies, most states came up with a detailed science assessment. They looked at current agricultural management practices as well as potential agricultural management practices to get an idea of where we could go about reducing nitrogen and phosphorus loss. And they also looked at the scale that these agricultural management practices would be needed at. So do we need a couple thousand acres? Do we need a couple 100,000 acres to reach our goal? And with this, Iowa, as well as the other 11 states, were asked to come up with plans that reduce their total nitrogen and total phosphorus loads by 45%. And this is a 45% reduction from both non-point sources, things like tile drainage, surface runoff from agricultural areas, but also point sources like wastewater treatment plants. Now in Iowa, if we were to get to this 45% reduction, say for nitrogen, about 41% of that would total nitrogen reduction, 41 out of the 45 would actually come from reducing from agricultural settings based on various models that have been done throughout the state. With our state's nutrient reduction strategy, the way we're going about trying to reduce nitrogen and phosphorus is by starting with, as you can see in the diagram on the left-hand side, kind of the small scale, edge of field, small watershed scale implementation. We assume that it'll take maybe less than 10 years to start seeing effects from these small scale implementations. Once we get better at implementing them, once we convince more people to implement them, we'll start seeing improvements at a larger scale. So instead of just seeing improvements off of one farm field, the more practices we put in, we'll start seeing improvements at Huck 12, Huck 8, larger watershed scales. And we're hoping that in believe by 2035 that we will be able to reach this 45% reduction goal for both total nitrogen and total phosphorus. Now, we have a couple different practice categories that can be used to reduce nitrogen and phosphorus loss. These categories are nutrient management, land management, and edge of field practices. With nutrient management, this has to do with things like the 4 R's of nutrient management, making sure you're using the right type of fertilizer, you're putting it on at the right rate, in the right time, and in the right place. We also have changes to land use, things like land retirement, but also the use of extended crop rotations, converting row crop to pasture hay, starting to use cover crops with continuous corn or corn soybean row crop acres, as well as things like terraces. And then also edge of field practices, which include buffers, saturated buffers, bioreactors, wetlands, and things like sediment basins. Now, when we're trying to implement these different nutrient reduction practices, for a specific area, we need to really get an idea of what we're trying to target to put the best practice for that area in place. So if you're looking at reducing nitrogen, you're going to use probably one type of nutrient reduction practice, whereas if you're trying to reduce phosphorus, you're going to use a different type of nutrient reduction practice. And this all has to do with the way nitrogen and phosphorus move with water. So in this diagram, if you pretend that black line is maybe the surface of a farm field, when you have precipitation hit the surface of that farm field, some of that precipitation is going to be lost as surface runoff. Some of that precipitation is going to infiltrate into the ground. And when you have surface runoff, it's not uncommon to have soil loss, especially if that precipitation is hitting bare soil. With soil loss, you also get phosphorus loss. Phosphorus compounds bind really well to soil. So whenever you have soil movement, you're likely going to have phosphorus movement as well. Whereas with nitrogen, especially nitrate, nitrate dissolves in water. So instead of nitrate binding to soil, nitrate is going to end up dissolving in that water. So as precipitation hits the surface, infiltrates into the ground, as that water moves through the ground, it's going to start dissolving different compounds within the soil, including nitrate. So that infiltrated water may eventually end up at a subsurface drain where it will be shot out to a stream or river. And with the movement of that water, you're also getting the movement of nitrate out of that farm field. So when you're thinking about practices to reduce nitrogen and phosphorus, if you want to reduce phosphorus, we typically try to reduce surface runoff, whereas if we're trying to reduce nitrogen, we're typically trying to either reduce subsurface drainage or trying to treat subsurface drainage that comes out of that area. Now, with nutrient management practices, things like the 4 R's, these are probably the oldest practices in place, the most used practices. While they're kind of older, pretty heavily used throughout the state, there's still a lot of opportunities to improve not just water quality, but also potentially improve profitability in some areas by fine-tuning the 4 R's, fine-tuning these 4 R's for your specific farm field. There's also potential opportunities for improvement in areas using livestock manure, making sure that the livestock manure application rate matches up with what's actually needed by the plants that are being grown in the field at that time. Now, land use practices, typically things like cover crops and terraces are put in place to hold soil within the field. So cover crops and terraces are really good as phosphorus reduction practices. Cover crops also have the potential to take up some nitrogen from the soil. So instead of that nitrogen leaching away with the groundwater, cover crops can take some of that up. Then with things like pasture hay and land retirement, you get benefits of both phosphorus and nitrogen reduction. Then one of our newly listed practices is prairie strips. Prairie strips can be put on either the edge of a field or strategically placed within a field to help reduce particularly phosphorus loss from agricultural settings. And then with the edge of field practices, many of these practices are focused on nitrate reductions. So treating or reducing the amount of nitrate that's lost from tile drainage water. One such practice is bioreactors. In the picture in the middle of the screen, you can see a wood chip bioreactor being installed. Now, the one big exception for edge of field practices is sediment basins. Sediment basins are designed for phosphorus removal. They trap soil particles, so they're also trapping phosphorus. And unlike our land use as well as our nutrient management, a lot of the edge of field practices are relatively new and they're developing technologies. So saturated buffers were created in Iowa. They were developed by Tom Eisenhart and some other researchers at Iowa State, specifically for nitrogen removal from agricultural settings. And then, we also have a newer practice, multi-purpose oxbows. Multi-purpose oxbows were just added to the approved list of nitrogen reduction practices this past fall, 2019. Currently, there isn't a creation standard for multi-purpose oxbows, but hopefully something will be in place in the next year or two. Now, with these different practices, while they're targeted for either nitrogen or phosphorus, they have different potential rates of nitrogen or phosphorus removal. Now, with things like edge of field practices, which are the bars indicated in blue on this graph, you can see a lot of these edge of field practices have somewhere between about a 35 to 55% nitrogen reduction potential. Whereas our kind of gold color bars at the top, these are our nutrient management practices, may have somewhere around 15% potential reduction. And then land use changes, especially things like pasture and land retirement or conversion to perennial energy crops, can have upwards of 75% potential reduction. Then for phosphorus practices, our green bars are once again changes in land use. The brown bar is terrace, and then some infield practices are gold bars. And you can see that some of these practices have almost a 90% reduction potential, specifically things like changing up tillage, going from conventional tillage to a no-till system has the potential to reduce phosphorus loss by somewhere around 90–95%, depending on your specific farm field. Now, for current progress, I'm going to be talking about 2017 to 2018 numbers, but the annual report for the Iowa Nutrient Reduction Strategy for 2019 just came out this month. So if you're interested in that, it can be found on the ISU Extension website. Now, for 2017 to 2018, some good achievements we've seen are conversion of about 1.8 million acres to CRP land. We've also seen terraces as well as wascobs, so a type of sediment control basin, treating about 290,000 acres within the state. There's been implementation of about 86 nitrogen removal wetlands, treating 104,000 acres, and then cover crops. Well, this is an older number. I believe this past year's number was closer to 1 million acres in cover crops, which is very good. Now, to actually get to our 45% reduction goal, it's going to take multiple nutrient reduction practices to actually meet that goal. Some practices work better in different areas. Some practices have better potential for nutrient reduction. So as part of the nutrient reduction strategy, a number of different nutrient reduction scenarios were modeled to see how many acres or how many of a certain practice and what combination of practices could potentially get us to a 45% reduction. So for this kind of example scenario that's in the graph on the left-hand side, this scenario is looking at nitrogen reduction. So it's estimated that about 10.5 million no-till acres, 12.5 million acres of cover crops, 7,600 wetlands, and 120,000 bioreactors, along with about 1,000 acres of prairie strips, would be necessary for Iowa to reach our 45% reduction of total nitrogen. However, if you look at the darker green bars on this graph, that's where we were at as of 2017. So you can see no-till acres were about half of what we needed in this particular scenario. Cover crops, we have about a little less than a tenth of what we need, and even less for wetlands and bioreactors. So you can see we have a very long way to go to actually reach 45% reduction, but we still have until about mid-2030, so about 2035, to get these numbers up. And I think we are trending in the direction of getting the numbers up to where we potentially need to be. Now, with these practices and with the nutrient reduction strategy, I want to point out that there's really no one cure-all. There's not one practice that we could put on every single acre of row crop throughout the state that would allow us to meet our reduction goal and also to allow for our agricultural industry to kind of continue as is. What we're going to need is really a multi-practice approach that's usually a combination of different practices to reach both our nutrient reduction and our agricultural goals in the state. Now, while the modeled scenario I provided kind of gives an insight into scope of implementation, that's not the only potential scenario. There are a number of different ways we could potentially meet our reduction goals. It's just a matter of getting these reduction practices in place so we can start working towards those goals. Now, with these different practices, while I mentioned kind of earlier why nutrients are important and reducing nutrients is important for Iowa and for the Gulf of Mexico, there's additional potential payoffs with these reduction practices. The first is improved local water quality, both for drinking water and recreational purposes. Some of these different practices also have potential to protect our soil resources. So anything that helps hold soil on the surface in the agricultural landscape helps to protect our soil, not only through potential loss, but also anything that has, say, roots, so cover crops, prairie strips, also help to increase organic matter in the soil. They help to build up the soil and they help to improve soil health. There's also potential for employment opportunities to implement these practices. Once again, I have a picture of a bioreactor up. It takes someone to design the bioreactor. You have to have somebody to excavate your bioreactor footprint. You need people to haul off that excess soil or remove that excess soil. You need someone to haul in wood chips to fill your bioreactor, and then somebody to do the plumbing in your bioreactor, making sure it's hooked up correctly and draining correctly. So potential employment opportunities associated with these various nutrient reduction practices. And for some practices like wetlands, prairie strips, there's also the potential to further diversify our landscape, providing additional habitat for wildlife, birds, insects, butterflies, and improving the beauty of our state. Now, shifting gears a little bit, so that was the Iowa nutrient reduction strategy. Now I'm going to start talking a little bit about the Iowa Nutrient Research Center and the role that the center plays in nutrient reduction. Now, if you're interested in the Nutrient Research Center, our website can be found at cals.iastate.edu/INRC/. And on our website, we have a list of research projects that have been funded. We have some news, various resources and publications associated with the research that's been done through our center, as well as a water quality research map, which I'll talk a little bit about later on. Now, the main goal of the Iowa Nutrient Research Center is to develop science-based approaches to evaluating the performance of current and emerging nutrient management practices and provide recommendations on implementation and development of new practices. So all of those nutrient reduction practices that I mentioned with the Iowa Nutrient Reduction Strategy, it's the goal of the Nutrient Research Center to help provide funding to look at ways to improve these technologies or come up with new practices that can be used to reduce nitrogen and phosphorus in row crop areas. Now, our research center was established in 2013 by the Iowa Board of Regents in response to legislation passed by the state. Our center is made up of 5 people. There's the director, Matt Helmers, myself, the program coordinator, Malcolm Robertson, our communication specialist, Anna Robinson, and our accountant, Wendy Bora-Diaz. Now, when our center was founded, part of the legislation that called for the creation of the center also defined an advisory council for the research center that would help kind of guide the direction of research and the center through time. Members of our advisory council include the Iowa Secretary of Agriculture, IDAL's Division of Soil Conservation and Water Quality, Iowa Department of Natural Resources, a nutrient researcher at the University of Northern Iowa, a nutrient researcher at the State Association of Private Colleges, the Hydroscience and Engineering, sometimes known as IIHR Center at University of Iowa, the Vice President of Iowa State University Extension and Outreach, and then finally, the Dean of the College of Agriculture and Life Sciences here at Iowa State University. Now, our biggest task as a center is to help allocate research funding. This research funding dollars comes from the state, and it's our job to help figure out where that research money should be allocated to. So for this research funding process, the first thing we do is we try to gather input from our various stakeholders on the research needs throughout the state. And our stakeholders include not just the individuals on the advisory council, but different government, non-governmental organizations, farmers, researchers throughout the state to get an idea of what are the current research needs associated with nitrogen and phosphorus in Iowa. Once we gather this input from all of our stakeholders, which we did this past February, we develop what's called a request for proposals. So we put together a short one-page document that kind of lists the different research needs that have been mentioned throughout the state and ask researchers at the 3 region institutions, University of Iowa, University of Northern Iowa, and Iowa State University, to develop and submit proposals related to those research needs. Once we solicit these proposals, we get them back and we put together a peer reviewer panel who will then review these proposals and make funding decisions on which proposals should be funded or shouldn't be funded. We just finished up our peer review panel at the beginning of July, and we're going to be making our announcements for our current year 2020 proposal funding sometime this August. Now, to date, so since the development of the center in 2013, we have allocated a little less than about $10 million to research to these 3 region institutions. We have research dollars that go to projects in land management, that go to edge of field research, and go to nutrient management research. We also have a 4th category that isn't listed in the Iowa Nutrient Reduction Strategy, and this is multi-objective research. Multi-objective research covers research that maybe falls into economics, sociology, or on-the-ground water monitoring. So something that doesn't neatly fit into one of those land management, edge of field, or nutrient management categories. Our multi-objective research category also provides funds to the IIHR at University of Iowa to maintain a number of nutrient monitoring stations at streams throughout the state. With the awards that we funded, most of these awards average about $110,000 over the course of 2 years. And for 2019, we had a total of 23 proposals submitted, 9 in-field, 6 edge of field, and 8 multi-objective research proposals. From this, we were able to fund 16. Unfortunately, due to everything going on in the state and in the world right now, we probably won't be able to fund 16 proposals for this year, but we're still hoping to fund a number of proposals. For 2020, we actually received 42 proposals from individuals at the 3 region institutions. Now, from all of this research that's been done since 2013, we've had either past or current work looking at improvements for nitrogen reduction in the 4 R's. We've had research on oxbow restoration. Oxbows are a type of wetland that you find along streams. We've had research on directing tile drainage water through riparian buffers. This is how we have the development of saturated buffers. We've also had research on the impact of denitrification practices on greenhouse gas emissions. So these various nitrogen reduction practices typically involve microorganisms that will take up nitrate, convert it to a nitrogen gas, which is then released to the atmosphere. So research that has been done looking at that released nitrogen. We've also had research on large-scale nitrate transport throughout the streams and rivers in the state, and have looked at different types of cover crop systems, not just looking at how they can reduce nitrogen, but also how they will affect the crops in the field, specifically how they may influence corn crop yields. And through the Iowa Nutrient Reduction Strategy, there's also been suggestions for potential future work. So our potential future work are things that have not currently been funded by the Research Center, but that we could potentially fund in the future. This potential work includes the use of 2-stage ditches, which are pretty popular in Indiana, looking at ways to monetize economic benefits derived from not just water quality improvements, but also other ecosystem services that these nutrient reduction practices could provide, and also just developing new technologies, new practices that can reduce nitrogen. For phosphorus, some of our past and current work includes looking at the current status of conservation practices for phosphorus throughout the state, looking at comparing water quality from land use change to phosphorus loss from corn-soybean rotations, looking at how sediment delivery to streams impacts phosphorus loads to streams, and then looking at ways to reduce not just infield soil loss, but also looking at ways to reduce stream bank erosion and sediment movement in streams to help reduce the loss of phosphorus from the state. Now, some of the potential future work that we could fund would be looking at things like the 4 R's for phosphorus management. Most of the time, people think of 4 R's in terms of nitrogen, but we also can start thinking about 4 R's in terms of phosphorus management. There's also potential for research to look at phosphorus transport on a large scale throughout the state, and also trying to validate the Iowa P index, making sure that it's working the way it should. Some of the, I'd say, the larger accomplishments or larger impacts from our funded research include the creation and the use of saturated buffers. Just this past year, we added multi-purpose oxbows to our reduction strategy practice list. There have been a number of research projects on cover crops. A lot of these trying to identify barriers for the use of cover crops, whether they're economic, social, or potential yield-based barriers. Also funded research that allows us to better understand how nutrients move throughout our entire landscape, how they move throughout the state in our waterways. And then exploring new research technologies associated with current practices. So one project that's currently ongoing is trying to see if there are other materials that can be used in bioreactors besides wood chips to help reduce nitrate. Currently, bioreactors throughout the state are using primarily wood chips, but we don't have the largest supply of trees in the state of Iowa. So there's a researcher who's trying to see, well, what do we have a lot of in the state that could potentially be used instead of wood chips? And one thing that's being looked at right now is corn cobs. And then finally, the development of prairie strips as an eligible CRP practice has come from some of the research that our center has funded. Now, while we're primarily focused on allocating research funds, we are involved in other activities. First off, we're trying to help connect stakeholders with researchers for potential future projects. And we also welcome input of future research needs as we develop these future grant proposal requests. So if you're interested in any of the research that's been done or being involved in these other activities, once again, you can find that information at our website at cals.iastate.edu/INRC/. This past year, we've also come up with a seminar series. Unfortunately, because of everything that happened this past spring, we had to cut it short. For the fall, though, we're going to bring back the seminar series and have it virtually. So you can log in from anywhere throughout the state. And we're going to be highlighting water research, past, present, and future within the state of Iowa. And these will likely be on Wednesday afternoons. We have also developed a water quality research map this past year. And this research map is designed to highlight water quality related research projects throughout the state of Iowa. Now, these projects include research that was funded by the Iowa Nutrient Research Center, but it's not limited to projects funded through our center. Most of what we have up there now is it's conducted by individuals at Iowa State University, University of Iowa, or University of Northern Iowa. And while that's what we have at the moment, that's not what we're limiting our map to. If you look at the picture at the bottom, you can see there are a number of different colored pins. Each of these pins represent a different project, and the different color of each pin represents the category type of that project. So we have the map set up. Say you're in Northwest Iowa, you can zoom in on Northwest Iowa, and if you're interested in edge of field practices, you can sort the pins by edge of field practices, so you'll just have those blue pins left, and then you can click on the different pins in the area to get an idea of what type of research projects are going on in your neighborhood. So if you were to click on one of these pins, it would bring up a project page that would include a project description. It would include the time frame of the project, who's conducting the research, any publications that have come out of that research, as well as contact information for the individuals conducting the research. Currently, we have about 45 projects listed on our map, but we're hoping to increase that in the near future and get better coverage throughout the state. Right now, a lot of our pins are kind of in central Iowa, but we really want to start highlighting projects that you can find all over the state. Now, to summarize that kind of quick overview of the nutrient reduction strategy and the Nutrient Research Center, I think it's paramount to realize that agriculture is a large and incredibly important part of our regional economy. And while it's a large part of our economy, and we need to make sure that the economy, agricultural economy, continues and stays healthy, we also have to realize that there are significant and growing concerns related to soil and water quality and soil and water resources in our state. So we have to come up with a way to not just continue agriculture, but to make agriculture, I don't want to say more sustainable, maybe more concerned with conservation practices to help reduce nitrogen and phosphorus loss from agricultural settings. And we already have a number of approaches to help mitigate nitrogen and phosphorus loss, but there's always the potential to develop more. And that's part of the reason why the Iowa Nutrient Research Center exists, to help provide funding to come up with, as well as improve the technologies that are currently out there. And finally, I just want to end this with, to really reach our 45% reduction goal by 2035, it will take substantial change. There's a lot that's going to need to be done in the state to start moving in the direction of reaching those goals. There's the need for both accelerated adoption as well as increases in research to try to improve the current technologies that we have. All right, so with that, if there's time, can I take questions?
Yes, great presentation, Kay. Thank you so much. We do have a few questions. Let's see, Jerry asked, is there any correlation between organic matter and the ability of the soil to retain nutrients?
Yes, I think there is a bit of a correlation. There is a correlation. It depends on how much organic matter you have, but also what practices are in place and how much nitrogen, especially nitrogen and phosphorus, you're putting into the system. So it's a correlation, but it's also kind of a balance. So there's not one number I can give you saying that if you have this organic matter level, you're going to help store this much in terms of nutrients. But yes, there is a correlation.
Okay, thank you. Dave asked, do you see sufficient or rising funding that supports land practices and strategies to reach goals?
So in terms of funding on the implementation side, yes, there has been an increase in funding. I'm sure a lot of people are familiar with federal dollars. There's also clear practices that were recently implemented through I believe it's CRP. Clear practices where you can get funding, not just funding kind of those yearly rental type payments, but you can also get funding for implementation of some of the practices. So I think there's somewhere around up to 50% cost share for implementation of things like bioreactors. And then there's also been an increase in funding throughout the state. That's really going to be dependent on the area that you're in. But if you talk to extension individuals or conservation specialists in your area, they can give you a good idea of what programs are available locally.
Okay, and Susan asked, who is on your peer review panel?
So our peer review panel, it changes with each grant funding cycle. The external reviewers are individuals from pretty much throughout the Midwest. So this year we had individuals from, let me say, Kansas, Minnesota, Wisconsin, and possibly Illinois. I can't remember off the top of my head, but it's usually individuals who are either in an academic or in a government research setting. And we try to make sure that we're not having conflicts of interest. So that's one of the reasons why we're going with individuals who are in the Midwest, but who are not directly related with the 3 region institutions.
Okay, let's see. Jerry also asked, is Iowa State University College of Design helping in water quality?
I've heard of a project that's being conducted. I believe it's an NSF-funded project that's being done in urban areas, looking at reducing nutrients from urban settings. But most of my work is more on the agricultural side, so I can't give you too much information on that, unfortunately.
Okay, if anyone else has any questions, please type them now in either the chat or the question and answer. I'll leave a couple seconds here to see if there's any additional questions. Okay, if there's no other questions, thank you so much, Kay, for the great presentation. And thank you to everyone who attended today. If you have any more questions for Kay or for Partners of Scott County Watersheds, please feel free to reach out. Otherwise, we hope to see you at August Forum. Thank you.